Okay. So let us go over the 2022 May paper. So because the 2023 paper we are anyway covering in the TS sessions, so you can also see the recordings of that. So hopefully you went through the Jan session recording so that I shared today. So just let me know if you have any doubts in that paper. Otherwise, we'll move on with this one, 2022 paper. Okay. So, okay, so this is the first question. We have n equals 1, 2, 3, 4, counter equals 0, answer equals 0. While n is greater than 0, do counter equals n mod 10. So mod is the modulus operator. So it divides by 10 and takes the remainder. So if we do it for 10, then for normal numbers, it will basically give us the last digit. So 1, 2, 3, 4 mod 10 is 4. 1, 2, 3 mod 10 is 3,
It's
etc.
just doing reversing, right?
Yeah, so we take the last digit and then answer is answer into 10 plus the last digit. So we are adding a 0 to the answer and then we are adding the last digit to it. So we are basically going over the number one by one and we are reversing all the digits one by one. And in here we are doing n equals n by 10. So we are also deleting the last digit each time. So when we are taking the last digit in the first iteration, it's getting 4, but then the 4 is getting dropped in this step. So in the next iteration, the number is 1, 2, 3. So when we do n mod 10 again, we are getting 3. So this way we are dropping each digit one by one in the last line, and we are taking those digits in the first line and adding it to the answer. So answer starts with 0 and it ends up becoming the reverse of the n. So here the question is, what is the output? So after reversing answer plus n. So after adding answer plus n. So n after the loop is over is obviously 0, because as you can see, the condition for the loop is while n is greater than 0. So only when we have only 1 left and we divide by 10, we get 0. So then this loop stops. So if n is 0, then answer plus n is same as answer. So the value of answer is the reverse of n. So 4, 3, 2, 1 is the answer here. So this is a simple, you can say, Python-like question. So hopefully this one is clear. Okay, so let's move to the next one. So here the question is, what is the expected output of the following command? So here we are doing find dot. So dot means the current directory. So we are finding in the current directory files which are of type directories. So not regular files, only directory files, and which are of the form of this name star space star. So here this is obviously not regex. This is the like shell like globbing syntax. So star means any character any number of times, star again means any character any number of times, so space. So this basically means all the directories which have a space in their name. It can be anything to the left of the space, also anything to the right of the space also, but a space needs to be there. And then so this find will obviously give output in separate lines, so each of the matches will be a separate line output, and then we are piping that to WCL, so we are counting the number of lines. So this entire thing will basically be the total number of directories which have space in their name, and in the current directory, and also in the subdirectories inside that. So because find will do a recursive search unless you change the max depth. So here the options are gives the total number of directories in the current working directory. So this is not correct, because if the name was not there, then this would have been correct. So this option is correct, gives the total number of directories with,
Shan, can you paste this command in the terminal and show us the example?
yeah, sure. So create, let me just create a folder with some folders. So here right now I don't have any folder. So if I create a few folders, so these are some folders without space, and then I'll create some folders with space. So you can see we have a few folders here. So some of these have space and some of these don't have space. So if I do find dot type D, and let me create some files also. So it's very easy. So I have some files and some folders. So if I do find dot type D name star space star, so this means anything space anything, and if I take the count of it, so we get three because we have three folders that have space in their name.
Okay.
So if I don't give the type, if I don't give the name, then we get all the directories. So there are six directories. So we get six plus the dot and dot dot, right? So if you see find, will give you the dot here. So that is also counted. So if I do type D, we are getting uh, C, B, C, B, C, D. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, sorry. So we have 1, 2, 3, 4, 5, 6, 7 folders. My bad. We also have D. So we have 7 folders and the dot. So total we are getting output of 8. And if we so if we do this, we get 8. And if I remove the type D also, then also the files which are XYZ are also counted. So it will become 11. So this way you can see find will give you all the files and folders. So this will give you recursively, even if there are files and folders inside the folders, it will also list those. So here the answer is gives the total number of directories with space in their name in the current working directory and also in subdirectories. So the third option is gives the total number of files with space. So the files is not correct because we are seeing type of directory, and gives the total number of directories with a dot in their name. So that is also not correct because we are not checking for dot, we are checking for space. So that's
So
why option B is
if
correct.
we want to check for dot, we need to use simple dot or backslash dot.
No, here simple dot will work because here dot does not have any special meaning.
But then simple dot means any character and then number of characters.
That is in regex, right? This is not regex.
Okay.
If this was regex, then you need to use dot star here, right? To match anything. So this
Sir,
is
I
not,
have a question here.
yeah.
Sir, instead of that minus type, if we just write minus t, then it will also work, no?
A minus T, so without YPE.
Yeah.
Let's check that. If we do minus T, then we get unknown predicate minus T.
No, minus d, only minus d. Find,
Minus D, okay. Option D is deprecated. No, so D is used for depth and not for like files of
direct.
type directories. Yeah.
Oh, okay.
So, and that is also deprecated. So we should not use D for depth also. So we should use minus depth for depth and minus type D for getting directories.
Okay.
Okay, so next is this one. So what command can be used to search for a blank line in a file named file1? So blank line is basically a line that does not have any characters in it. So the first question is, first option is grep backslash n file1. So this is just searching for new line. So even lines that have characters in it will obviously have new line at the end. So this will match all the lines. So that is not correct. The second option is grep quotation space quotation. So here we are searching for space, whereas a blank line ideally will not have anything, not even space. So this option is also not correct. The third option is correct. So here we are searching for a line which starts and ends. So as you remember, the hat is the anchoring for start of the line and dollar is the anchoring for the end of the line. So if we do grep hat and dollar, this means a line that has nothing in it. So this is how we search for lines that don't have anything in it. And we can also use the minus v dot to do it. So for example, if I open this X file and I add some lines that have something and some lines that are empty.
So can we do minus v and dot?
Yes, we can also do that. So if I do grep minus v dot, this will, and give the file name, of course. So this will print only those lines that are empty. So you can see if we do see, get the count 3. So there are 3 empty lines. And we can also do the grep starts with and ends with and X. And here also we'll get, there are 3 empty lines. So both of these are correct way of approaching this. So this one is again not correct because we are searching for new line. So just the presence of new line does not mean that the line is empty. So then the next question is the below text is contents of my CPU info. So that is a file. That file has all these information, and select the command that will print the number of CPU cores on your system. The number of CPU cores is given in the text as the value to the key CPU cores. Thus your output should be 4. So here you can see that we have this line CPU cores, a lot of spaces, colon 4.
Okay,
So
okay. Now, without showing the answer, can we try?
yeah, so can you guess what will be the answer for this? So you have this file which has multiple lines, and you have this line.
So we can like pipe out the CPU cores to a so pipe it out and then maybe use the trimming, the truncating and take the second field with cut, na?
Okay, so what will be the command? So first you
So
have this file, yes.
first we will take the file, then pipe symbol, then egrep CPU core, and then
Why do
I
you need to pipe the file into egrep? You can directly give the file to egrep, right?
okay,
Yeah,
then egrep CPU cores.
yeah,
We will get that particular line,
yeah.
and then we can divide it in two parts, I guess,
We can
How?
use first we need to use PR, right, to remove the extra spaces and then we can use cut.
or we can
Uh,
divide
field
it in
separator
two
as
parts
colon.
using.
So you don't need to remove the extra spaces because we can anyway split by the colon, right? So
Yeah,
we
yes.
don't care about the extra spaces.
So
Yeah,
We can use cut command here and use the
Yes,
yeah.
delimiter.
yes. We can use cut to cut the line which we got using grep, and then we can get the second field. So it will have space and 4. So then we can use the tr to simply delete spaces if you want. So we can use tr minus d to delete the space if there are any space. So that can be one way. So let me create a file. So I cannot copy this entire thing. I think if we run cpuinfo, it will come.
you can just simply write 2 3 lines CPU core,
Yeah, yeah. Let me just write a few lines.
1 or 2 lines, just processor 1 2, and
Yeah. So I'm trying to keep the format as same as possible. I'll not have all the lines, just a few lines. And then we have this CPU space code, CPU codes, and then here we have 4. And let's say I have something else. So this FPU, yes. Okay. So if I save this, so you can see this is the file. So what should we do? First, we grep out CPU cores, right? So I grep CPU cores from this file y. So this gives us, out of all these lines, only this line which we are interested in. So then, which command do we use?
cut command
Yeah, so we
Cut.
can use cut to remove the colon.
and
So,
minus F1
so F1 will give you
F2,
this
not
part, right?
0. So 2, I guess, 2 second.
F F2, yes. So if you do F2, you get space and 4. So here then you can, how can you remove the space?
TRD space.
Yeah, we can do this way and we can remove the space. There is another way to do this. So instead of doing these two things, I can directly use again grep. So how can I do that? So basically this, let me just remind you, this gives us this output. So how can I use grep to directly get the number?
Just write 4.
Just write
4
0,
is not always going to be the answer, right? So
0 to 9.
yeah, so okay, 0 to 9 will work if my answer is always single digit.
Star. Also, right? Star.
Okay, dot
Uh,
star. No, no, but that will take.
no, you don't need dot star, you just need star, right? So 0
Star,
to
yeah.
9 star. So 0 or more. So ideally it should be plus, so 1 or more. Star will also work because ideally this will never
Yeah.
be empty, but we should ideally use plus here. So this will only match that. So how do I only get that part? So if I print this now, Entire line
as
is
O.
printed. Yes.
Minus V,
No,
not
not
minus.
O.
minus O, right? So we want to only print this part. So this is also a way of solving this. So instead of cutting and then tearing, I'm just telling grep the exact regex that I want, and then I'm using dash O to only print that part.
Okay, can we use that square bracket then semicolon digit that one?
Yes, yes, we can use that also. Colon, right? Not semicolon. Yeah, so this also gives you the same output. So here you can see, let us see what is the options. So here also we have a help, right? So I think in the options they have also done using grep minus o. So you can see minus o help, they have told you how it works. So the first option is grep CPU my CPU info. So this is wrong on multiple levels, obviously. So if you just grep CPU, you can see there are a lot of lines with CPU megahertz, and then CPU ID level. So this will give you a lot of lines, and it will also not split out and give you only the value. So it will give you the entire line. So that's why the first option is not correct. The second option, we are doing grep O CPU cores. So what will this print?
Just print CPU cores. No?
Yeah, just the word CPU cores, right? So that is also not what we want. We want that line, but we don't want the word CPU cores. We want the value after it. So this is not correct. The third option is basically what we did, right? So grep CPU cores the file, then pipe egrep O digit plus. So here we are using extended regex. If we don't use egrep, then this plus has to be escaped. So this will be backslash plus. So plus means one or more than one. So from this line, which is got by grepping CPU cores, we only want to print the pattern where there are one or more digits. So that's why the first is correct. And why is the second last one not correct?
because we are using minus o here in the first part itself.
Yeah. So what will happen?
It
So
only
it will
prints
just print
Use
CPU
CPU
core
cores.
and then there's nothing digit on the
Yes.
other ones, so it will print nothing.
and
Yes.
nothing will be the
Yeah.
standard output to the
Yeah.
that pipe we are
Yeah.
using.
So this grep will return exit code of 1, and nothing will be printed to the screen, because this grep will not get anything digit in the input at all. Right. So only the third option here is correct. Okay, so let's see the next one. So what is the output of the following script if the input to stdin is 45.53? So let us see what the function is doing first. So here we have a function operate, and we are first in the script, we are first reading one input line of two standard in into the variable var. So 45.53 is stored in var. Then we have this function which does temp equals $1. So $1 here is the argument given to this function and not to the script. So then temp equals temp percentage dot star. So what does this mean? Percentage dot star.
I believe
So
it's taking like the last,
50.
like after the point, whatever is there, it's taking, right?
it's
Uh,
dropping that, right? So
Dropping it.
yeah, person means drop from right side. So from right side, drop as little as possible, matching the pattern dot star. So here dot star is not the regex dot star. Here dot star means dot as the literal dot symbol, and star means anything. So
What do
anything
we use for dropping from left side? I forgot.
percentage.
percentage.
Sorry, not
Ah,
percentage.
Hash,
Percentage is for right side. The pound
hash
symbol,
tag.
yeah.
hash. Yeah. So this is from the right side. So dot and then anything. So basically this dot 53 is being matched and dropped. So only 45 is left. So temp now has 45, and then we are printing temp. So we are printing 45. And then what we are doing is we are calling this function. So echo uh, then this command evaluation operate var. So operate is name of the function, and I'm giving it the argument 45.53, and it will then print 45, and that I am capturing and giving to echo, and then echo will again print it back. So echo prints 45 in this case. That's why the answer is 45.
Or just he want to check variable scripting.
Yeah, yeah. Also, like this confusing way of done, right? So you, ideally, what you will do, you'll just call operate $var, and that will do what you want to do. But here they have called operated $var inside this evaluated subshell and then taken its printed value, stored it, and then printed it using echo. So roundabout way of printing. So this also might confuse people. Ideally, it's just basically taking this and dropping anything from dot till the end from the right side. Okay, so let's see the next one. When the command ls minus l is run on the current directory, the output obtained is this. So in the current directory, we have all these files: ran1, ran2, ran3, ran4, script.sh, and test.sh. So, and these are the permissions of the files. So from here only we can see all of these are files and not directories because they start with a dash. So what is the correct output format for this bash script? So here we are doing for line in ls. So this backticks is the same as this thing. Oh, sorry, I think I missed one question. Yeah, so we have one question here. So after this question, let us come back to this question. So this backticks, the way they have called ls is same as calling something in the dollar and then round brackets. So both are the same. So here we are basically first calling ls, and then on the output of ls, we are running a for loop. You can see here all the files don't have space in them, so this will not cause any issues. This will simply have the 5 files as 5 different words, and the for loop will iterate over 5 of them, and each time the variable line will contain name of that file. So then I'm doing details equals ls minus l dollar line. So I'm doing the long listing of only that file, one file at a time, and that I am storing in the variable details. And then I am echoing dollar line colon dollar details colon 4 colon 6. So what does this mean? Colon 4 colon 6.
So second line,
From the fourth index, take 6 characters, right?
Yes. So what is the what is the first index that it starts from? 0 or 1?
1,
0, I guess.
0, right? Yeah. So in
Zero.
awk it is 1, in bash it is 0. So
uh,
what is the fourth index here? 0, 1, 2, 3, 4. So from the group permissions first bit, right? And 6 means 1, 2, 3, 1, 2, 3. So both the entire group and everyone permission, the last 6 digits or characters of this permission set, that is printed. So we are printing line and this. So line contains only the name of the file, and this substring contains only this. So it will only basically print ran1.txt colon r dash dash r dash dash, then ran2.txt colon r dash dash r dash dash, like this. For this last two, it will be r dash x r dash x, right? So that's all this for
Shan,
loop.
one doubt.
Yeah.
The ls we are printing in current directory, right?
Yes.
Okay, in current directory, let's say we will get first rnd1.txt,
Yes.
but then ls minus l, it will give some files. How we are sure that we will get these files only?
No, no. ls, if you are just running ls, it prints all the files in the current directory. So it gives you ran1, ran2, ran3, ran4, script sh,
Okay,
test sh.
correct.
If I'm doing ls minus l, the percent, the dollar line. So what is the value of dollar line?
Let's say rnd1
So
first txt
it's
file.
it's the name of a file, right, in the current directory. So if I
Okay,
am doing ls minus l and then name of a file,
so
it will
details will be first line only.
yes, it will be only that line. So for
Okay,
example, here you can see ls minus l prints all the files in my current directory. If I do ls minus l, let's say c, so then it will so, okay,
you
where is
can
it?
take x is a file.
Okay, yeah. So if it's a folder, it will go inside and print that. Sorry. Yeah. So if we, let's say, have a file and if I say ls minus l x, then it will print only the long listing of that file and not anything else. So if it's a directory, it will try to go inside that directory and print what is inside that. So, but if it's a file, so xyz, so it will only print that file's long listing. So because we are using this for line in ls, so this line variable contains the name of the files. So in each iteration, I'm only printing the long listing of that file and not anything else.
Okay, thank you,
Yeah.
sir.
But this will not work if this was a directory, right? As we saw.
Even I thought I didn't say the .txt. I thought it's a directory.
Yeah, yeah, yeah. So if it's a directory, no, so you don't need to see the extension. So the first character here will tell you if it's a directory or not. So if it was a D, then it will be a directory.
Yeah.
Yeah. So here, fortunately, all of them are lines, files. So that's why it works. Otherwise, this will not work for the directories. So then the options are obviously, so this here they have not expanded the basically this thing. So this first option is incorrect. If you're doing it this way, it will actually take the substring as you told. So the second option and the third option is incorrect because they have not taken the substring correctly. And the fourth option is correct because they have taken the substring correctly. And in the fifth, basically, they have again taken the substring incorrectly, right? So this is the zero based and one based difference. So if you think it's one based, you will mark this. If you think it's zero based, you will mark this. So in bash, the indexing is zero based. Right. So, okay, let's see that question which we missed. So here the question is, we have this set command. What does the above command do? So sed minus n, also what minus n does is told to you. So it will suppress automatic printing. So it will not print each line unless we specifically mention to print using the p. So it will match this. So this is digit and then 3. So we are matching lines which has 3 digits or more. So if it has only 2 digits or if it has only 1 digits, then this regex will not match. If it has 3 or more digits, then this regex will match. So although
Is
like
it not exactly three, or
yes,
because
so
there are already three, it's just
no,
going
this
on?
regex means exactly 3, but because we're not saying like for example start of line, end of line, right? So I'm telling just
Yes.
match a regex of size 3 which are digits. So it can match a substring also in that, right? So if we have 4 digits, it can match the first 3 and tell that regex is successfully matched. So
If it contains a, it should not be continuous, right? 3 digit.
no, it has to be continuous.
It
Oh,
should be continuous for the
okay.
summer.
Yeah, because we are matching a digit and then 3. So this means 3 consecutive digits. So the digits can be different also, but they have to be continuous. So, and then we are printing that line. So P is a command to print that line. So it will not print any other line, only those lines that have 3 or more consecutive digits.
And if we remove p, it will not print anything.
No, it will not print anything at all. So I think if you remove P, it might throw an error that you have to give any command. So if we give, let's say, some other command like D or something, then yeah, the output will be empty. So the P is for printing. So because we have minus n, so by default the lines are not printed. Only if we match this and then we do this P command, only that line will be printed. So it
Okay.
prints the line having 3 consecutive digits. So the other options are prints the line having only 3 digits. So this is wrong because even if it has more than 3, that will work. Prints the line having at least 3 digits. The reason this is wrong is because it does not mention consecutive, right? So if it has 3 or more digits separately, that will not work. It has to be consecutive. And the fourth option is prints the line having at most 2 consecutive digits. So obviously this is wrong because it tells at most 2.
So
So
if we want to write in egrep, so we will write as sed minus capital E, then minus n, and then same command with square bracket 3 only, right?
no, so a few things wrong with your statement. So I think you mean ERE, right? Not
Yeah,
E.
yeah,
Yeah.
ERE.
So if you're using ERE, then yeah, you will use the capital E here, and this digit part will be the same. But here you don't have to escape the curly braces.
Yeah, yeah, the square 3 only, right?
No, it's not a square bracket; it's a curly bracket.
Yeah, sorry, curly bracket 3
Yeah.
only.
Yes, yes. Curly
And
bracket open
what's
3.
the meaning of curly bracket in normal grep?
So in BRE, the curly brackets are the literal symbol. So if you want to actually match the curly bracket, so I think that was one of the questions in a week 4 practice, right? So this last and second last. So if you want to actually match a curly bracket, you use curly brackets in BRE. Whereas if you want to like have this special meaning, then you use BRE and don't escape it, or you escape it in BRE.
Okay.
Yeah. Okay, so let's see the next question.
Sir, in case of at most 3, how Can you show me that?
Yeah. Which one?
Yeah, this question. That the
Yeah.
question is asks to print the line having three consecutive digit, at most three. Then how can we
Yeah,
process?
if you want at most three,
Yeah.
then you basically have to do something like so this is digit, and then uh, to the left of it you should have a not digit as much as possible, and to the right of it not digit as much as possible. So something like this. So let me create a file. So here let me have some lines which have two, some have three, some have four. Right. So here, sorry. Okay, so here if I do this thing, right? So I'm just using grep to make it easy to see. So if I am doing 0 to 9 bracket 3 in extended regex, so this, and I again forgot to give the file. So this will print the ones which have 3 and 4 also. But if I want only 3, then a few things we can do. So for example, here I only have the line where only the digit is there. So if that is the case, you can simply put a start of line and end of line, and that will be all you need to do. But for example, if the line can contain other things also, right? So for example, if the line contains some other text also to the left and to the right of the digits. So, right, so let me actually do this for all of them. 1 second. So I'll go in the beginning, I'll add some things, and then I'll go in the end and I'll add some things, and I'll do it for all of them. Okay, so if we have it this way, then if I print the file and if I run this one, so you can see it's matching the ones which have three consecutive digits and more than three. But if I do this now, it will not work because I'm asking that the line should only be three consecutive digits. So that might not be the case. So in that case, what you have to do is you have to basically say that anything to its left should be any character other than digits, and anything to its right should be any character other than digit. So how can you say any character except digits?
Can we give bracket and then up the uppercase and the hat and then digit?
Yes, exactly. So this basically means that any character except digits. So then I want this to be present as many number of times as possible, but also zero number of times if it is not there. So we use a star to mean that. And that same thing, we again put it on the right side. So not digit, any number of times as possible. So then you can see this will match. Okay, so where is this not matching? And okay, so we have to also put the start of the line and end of the line. So that should be the entire line. So then you can see only the lines that have exactly three consecutive digits are matched, and lines which have four consecutive digits are not matched. Right, hopefully this makes sense, right? So we are matching basically not digit to the left of the three consecutive digits and not digit to the right of the three consecutive digits. And we are telling this should be the entire line. So we are wrapping that with uh, hat
Can
and dollar.
can you write one command for me?
Yeah,
Grep,
yeah. So I'll use
then
greppy because grep is deprecated.
okay, then square bracket, then 0-9,
Yeah.
and then curly brackets 3 curly brackets, and then both end slash b. Will this work?
Sorry, I didn't catch the last part.
Uh, slash b.
Slash, oh, backslash b.
Oh
Okay.
yeah.
Okay. Got it. Word boundary. Yeah. So this will work if you let's say want to only match the digits if they are in a word boundary. So let me give the file also. So in this case, it will work. But if let's say our file was not separated by space or some word boundary, so if we just wanted to match three consecutive digits, so we didn't care if there was a space or before or after it, in that case, it would not work. So for example, if I change the file so that some of these answers which should match, they are like touched with some other word. So
Then what we can do, then instead of this slash b, can we write dot star?
Yeah, if you do dot star in both the places, right? So if you
Yeah,
do
both
dot
the places.
star, then it will simply match all the lines. So any lines which has three and any line which has four. So dot matches anything. So a digit is also matched by dot. So this will not work. And if you basically see this, so this the earlier one, this is only matching this one and not the one which is connected with another word. So if you do it this way, then it will match both of them.
Okay.
Right. So if you're told that it is always a word boundary, then obviously it's simpler. You can simply do this backslash b backslash b. But if you are not told it's a word boundary, so you have to understand what you're trying to match. So you're trying to match three digits, and to its left it can have anything which is not a digit, and to its right it can have anything which is not a digit. So I don't care if it's a space or if it's a letter. So in that case, you have to match this way. Whereas if you are only interested with the word boundary, so here actually instead of doing backslash b, because we are surrounding entire thing with it, I can directly also put it as a flag w. So that will also do the same. And similarly in this one, so instead of surrounding the entire thing with caret and dollar, I can simply put x here, which does the same thing. So basically the same thing. So instead of, if you don't want to use, like basically if you're matching the entire regex and putting backslash b in the left and right of it, then instead of that you can put dash w flag. Similarly, if you're doing it for hat and dollar, you can put dash x. But this will obviously not work if it, like if the backslash b is part of, like you're using it in the middle of your regex. So you want to match something else also. So this is basically a shortcut of putting backslash b in the left and right of the entire regex.
And same question, can we just write the what you wrote above without using the first symbol that you wrote after minus e?
Which one? The
Uh,
quotation symbol.
yeah, after quotation symbol, uppercase symbol. Yeah, if you
Oh,
remove.
okay. This is a caret. Yeah. So if you don't have this, this
No, no,
means
not this
the,
one. Outside of this that we.
okay, this one.
Yeah, if you remove this
Yeah.
and the star from the last part also.
No, this star. No, we were using dollar here. That means
Yeah,
end of line.
if we remove star also
Okay.
now, and one star in between also, if we remove that, so what it's saying, right hand side should not be number, right?
Yeah. So it should be a three-digit number. On its left, it should be a non-number. On its right, should be a non-number.
And can we do one thing, add one open bracket, and can we put abcd into the square brackets also
Uh,
in the starting,
okay.
very starting, open bracket.
Yeah, like
uh,
this, right?
yeah, write this, and capital az also,
Yeah.
and
So yeah.
then we can put this 09 inside the same square bracket, and then put this. I
Okay.
want to say put yeah, put all condition inside the. Can we do like this?
No, this simply means that there should be three digits, and on its left, it can be any number or any
No,
digit also.
now use that upper symbol.
No, no, no. So the negation only works at the start of this. So I can say negate the entire thing. I cannot selectively negate something.
Sorry.
I cannot selectively negate some groups and unnegate some groups. So if I put the negation here, it will negate the entire group. If I don't put it, it will match the entire thing.
Yeah,
So
yeah,
we
but
cannot
we
put it.
want to neglect all the group, no?
Uh, no, if you don't want to negate everything, you just want to negate digits. So to the left of the number can be a alphabet. I don't care
Okay,
if it's
digit only. Then we can remove az and this part.
yeah.
This will work, right?
Yeah, so this will give you the solution. So you'll basically matching anything that has non-digit to the left and non-digit to the right and three consecutive digits. But if this file has, like if one line has multiple occurrences of this, so for example, if there is this same line there two times, right? the same line there two times. So then this will print match both of them. Whereas if I want to match only those lines that has exactly three digits consecutively, so then we have to match till the start and end. Then this will not work.
Okay.
Then we have to use what we were using earlier. So non-digit star, three digits, non-digit star, and the start and end of the line. So then it will only print the correct line, which has only three consecutive digits.
Okay. Okay.
Right. Okay. So let's move on. So the next question is when the command ls minus l is run on the
We
current
already
directory.
did this. Yeah.
Okay,
Yeah,
we
we
did.
just finished this.
Okay, yeah. So let's move on to the next one. So here the question is, what will the below awk script do? So we have awk and arr $0 does not equals one, then arr $0 plus plus print, and then my file. So let's go through each thing one by one. What does print does?
So it prints the
Everything.
entire record, right?
Yes, it prints the entire record, the entire line. So for whichever line this action block is running, if we don't give anything to print, it will print the entire line. Yes. And then what does this mean? ARR $0 plus plus?
It increases the count of that. No?
Yes. So this is like a dictionary, like a Python dictionary. So I'm accessing the key using the entire line. So I'm telling create a key if it does not exist in the dictionary ARR, set it to 0, and then increase its value. So if it exists, increase its value. If it does not exist, then basically first it will set to 0 and then increase it to 1.
So
So
ARR is not a array; it's a dictionary.
yeah, it's an dictionary or an associative array.
Mm, what is it? Associative array and dictionary. Dictionary, I
Associative
know, but
dictionary is the
simple Python dictionary.
yeah, dictionary is the word used by Python. In general, they are called associative arrays.
Oh, okay.
Yeah. So any array where you don't index with a number, you can use any key. So they are associative arrays. So here the key is the entire line, and the value is basically the count of that. So we are incrementing it to 1. And here we are telling that we will run this only if the uh, ARR $0 does not equals 1. So if
$0 means it takes the entire line, right?
yes, the entire line.
Yeah.
So the key value will be entire line.
Yes.
Oh. Oh, sorry, key will be entire line and value will be number 0, 1, 2, 3 like this.
Yes, yes. So for the first time that line is encountered, that value will be 0. So 0 does not equals 1. So this is satisfied. So it will come inside and it will set it to 1 and it will print it. So the next time that same line is encountered, then here this value will be 1 does not equals 1, which is false. So it will not go inside anymore. So this actually is not the count of the lines. It will only be either 0 or 1. So if that line has not been seen, it is 0. If that line is seen, it
So
is
this
1.
just prints every unique record, right?
Yes.
Okay, so it's removing duplicate lines.
Yes. So like from the my file, it will print only those lines which are unique. So let's see the options. Second, occurrences of duplicate lines, distinct lines in alphabetical sorted order, distinct lines in order of first occurrence, the lines that are present more than once. So obviously we are not sorting anything. We are simply going in the same order as they are in the file. So it's not in the sorted order. And as we saw, it is not the second occurrence. It is like the first time they are present, it's printed. So it will print the distinct lines.
It, it will be great if you can show us one example, very small example, anything.
Yeah, sure. So, for example, let's say I just copy this line. So this line is present two times here. And if I create a awk script, so here what are we doing? So this is a user bin awk script. And here we have arr $0 does not equals 1. Then
What
arr,
we usually do is we write print $0. That means entire line.
yes,
It's
print
same
$0 is same
same
as print.
$0.
Yeah, both are same. Both will
Okay.
do the same thing. Print and print $0 are the same thing. If you don't give any argument, it will print the entire line. So the semicolon is basically a way of writing entire thing in one line. So if I do it this way, it will be a syntax error. So I have to put a semicolon, or better yet, we can put it in separate lines. So this, I think, is the entire script. Yes. So let me now run it. So we run it with using the awk -f script.awk on the file, which is Z. So you can see each line is printed once, and this last line which I copied, so we have twice of that, that is also printed only once. So all the distinct lines are printed, and even if a line is duplicated not consecutively, like if it's let's say present here at the top somewhere, still it will only print it once. So this is not how unique works, right? So unique only removes consecutive duplicates, whereas here you can see it removes globally duplicates. So the first occurrence is printed, and all the duplicates afterwards are not printed. Right. So hopefully that makes this clear.
Yeah, yeah. Thank. It's
Okay.
very much similar to PPA question, right? In one of the PPA question, we need to do this.
Uh, I'm not familiar. Which one?
I guess PPA two practice assignment
Okay.
coding question.
Okay. Yeah, I haven't gone through that one.
Okay.
So yeah, so there are multiple ways to printing global uniques. So one easy way is to simply sort the file and then take the unique. But then the what happens is the output will also be in the sorted order. So if I don't want the output to be sorted order, then we can do something like this. So this will, without changing the order of the files, print the uniques in the order of occurrence. So here you can see the order is different from the earlier output. But this also prints the unique ones. So this one is only printed once.
Can you print array inside somewhere? I just want to see how array looks like. Their
Yeah,
dictionary.
sure. So after the end, I can print it. So we can basically print it this way using a for each loop,
No,
same as
there's
how in Python.
complete array with the key value pair.
Yeah, so this will print, okay, so not this, sorry, I don't know why it did this. Yeah, so this will print the key and the value we can print using ARRI.
Can't we just write simple print array?
Uh, okay, so let's try that. So if it's an array, if we simply print ARR, let's see what happens. So if I run this, so you can see you cannot print something which is an array directly. So attempt to use array ARR in a scalar context. So you cannot treat a vector as a scalar. So print can only print scalars and not
Okay.
vectors. So here you have to iterate over it, right, using a for loop. So this is
This
simple.
for loop will similar to the Python for loop.
Yes, so I in ARR, so it will give you the keys of the dictionary, and you can print the key and you can also get the value using ARRI. So if I save this and I run this, so okay, let me also print some demarcation so that I can understand we are in the end. So we can see this is basically each unique line, that is the key, and the count of that as 1.
Okay. Thank you so much. Shan.
Yeah, okay. So let's move on. Okay, so here is part of an information from awk manual. So they have let you know how the gsub command inside awk works. So this is very similar to how sed substitution works, but we can do it inside awk using the gsub command. So R is the regex we search for, and S is the string that we substitute the regex with, and T is the string in which we search. So we can optionally not give T also. So this bracket means that this part is optional. So if we only give 2 arguments, which is the regex and what to replace it with, then this will act on the entire line, which is $0. So you can see similarly that is also how print works, right? If you don't give any parameters to print, then it will print $0. Similarly, if we do gsub with only 2 arguments, so the what to search for and what to replace it with, and not on which string to do that, then it will do it on the $0. So the contents of the file is given below. These are name of 5 people, and what will be the output after running the below command. Awk on the file my file. So here we are doing g sub, and then this is the regex that we are searching for, dot star, and we are substituting with nr and then colon and then at sorry and. So and is also mentioned how and works here. So you can see and in the replacement text is replaced with the text that was actually matched. So use backslash and to get a literal and. So if you want to actually use the symbol and, then you should use backslash and. But if you want to get entire search thing in the replacement, you can use the ampersand. So you can see the ampersand is used here. So
Does
the
this
question,
give the number of times each letter is like appearing or something like that?
okay, so why each letter?
Because dot star will match everything, and
Yes.
then NR is number of records. So maybe it's each word how many times it appears.
Okay, so if I just match dot star, what will be the match? So for example,
Everything,
if
right?
yes, so for example here if I do
I
grep,
think we will get complete line, right?
yes. So if I do grep dot star in this z, so it matches the entire line, right, and not just a word. So it will match as much as possible. So even if I do minus o, you can see that the entire line is the match, not just one word. So because it is working on the $0, right? If you remember the third argument, if you don't give, it's working on $0. So this match of dot star is the entire line itself. So we are matching the entire line, and then we are printing NR. So what is the NR?
Number of
Number
rows.
of records.
Yeah, so that line number of that line, and then a colon and then ampersand. So the entire line again we are printing. So like in a higher order way of thinking, what is this doing? Like what is this printing?
Giving is basically this or numbering it, right? Like bullet points.
Yes, yes. So it's just simply numbering all the lines. So all the lines are printed in the exact same order they were. Nothing is changed. Just the line number is added to the left of it. Right?
Even they are in quotation and will still work.
Yeah. So basically, this substitute string it has to be in quotation only. It cannot be what you say a regex. So it has to be a string. So here in awk, if you have two strings or two like one number, one string side by side, that is treated as concatenation. So here we don't use the plus symbol to concatenate. Writing nr and then a string is same as concatenating the value of nr to the string.
What I thought, it will give a number, NR will give a number,
Yes.
then we need to print semicolon and symbol,
Yeah. So the no. So basically,
because
you give
it's in
the
a quotation. So
yes, yes. So you have to give it
quotation
in the
should become
quotation itself
string, right?
because yes, it is a string. So if you see the synopsis of gsub, s has to be a string. It cannot be anything else. So the r can be a string or it can be a regex, what you are searching for, but the s has to be a string. So for each substring matching the regular expression r in the string t, substitute the string s. So s will always has to be a string. So here you should give the second parameter as a string, and the ampersand has to be part of that string only.
Okay, okay.
So G sub will automatically, if there is an ampersand, it will replace that ampersand with everything that was matched. But if you want a literal ampersand, then you have to use the backslash ampersand there.
Looks like first option is correct, right?
Yes, so the first option is basically the same order of the lines and same lines, but we just simply number the lines. So 1, 2, 3, 4, 5. So another thing to remember is that NR starts with 1.
Yeah.
So here you can see like the text nr will not be there. So if we had put nr inside the string, so if it was quotation nr colon ampersand quotation close, then this second option would be true. But because it is outside, so first the value of the variable nr is taken and then it is concatenated with this string. So that's why this option 1 is correct, 2 is incorrect. And 3 and 4 basically tests if you read that how the ampersand works. So it will not print the literal ampersand. That will work if we do backslash ampersand, and it will also not be empty because we are matching the entire line. Right, so that is this question. So the next question is, consider a regular list as shown in the sample input that is stored as a single line in the file mylist. So we have a file called mylist that contains something like this, square bracket 1 comma 2 comma 3 comma 4 square bracket close. Select the set script to pretty print this list such that in the output, the first and the last line have the starting and ending brackets, and the elements of the list are printed between the first and last lines, one element on each line indented by a tab. The elements should be printed in the same order from top to bottom as they appear in the list from left to right. So basically the same order 1, 2, 3, 4 should be printed 1, 2, 3, 4. And here all the elements should be tab indented. So there should be a tab and then 1, tab and then 2, tab and then 3, tab and then 4. So we have to do it with sed. So how can we do this? So
Can
there
you
are
again explain the question?
so the question
Can we
asks you to
replace anything that's not a bracket and then do something like that?
okay, not a bracket. Yeah. So basically, the question asks you to take a input like this and make it a output like this. So the brackets will remain in zero indentation, and each element in the list becomes first level indentation.
You have to
And
print like the first element, the second element like that,
yes,
and
yes. So one thing you can do is you can basically replace the comma with something else, right? So what should we replace the comma with?
new line tab.
Is it just new line tab, or so we
Just
still need
New,
the comma, right?
oh, not comma new line tab.
Yeah, so we replace comma with comma, new line and tab. So that will work for the first three lines. And in the fourth line, so we basically replace the closing square bracket with, what do we replace this with?
New line and closing bracket.
Yes, so we replace closing bracket with new line and closing bracket. And what do we replace the opening bracket with?
Opening bracket, new line tab.
Yes, exactly. So you can see opening bracket becomes opening bracket new line tab. The comma becomes comma new line tab, and the closing bracket becomes new line closing bracket. So that is something that I can think of. Let's see what are the options for this. So if you want, we can also try this first. So let me close all this. Let me create another file and let me add this. So basically 1, 2, 3, 4. And here what I want to do is I will create a set script because we have multiple things to write. So the first thing we are doing is we are substituting the opening bracket. So this is a literal opening bracket, so I have to escape it. I'm substituting the opening bracket with opening bracket and then new line and tab. Okay, so this looks good. And then I am substituting the comma with comma, new line, and tab. I think that also looks good. And finally, we are substituting the closing bracket with the uh, new line and then the closing bracket. So new line and then closing bracket. So let's see if this works. So let me run a set script. So we run it in the same way as grep script and awk script with -f. So this is script.set on the file list. So yeah, you can see from the input, which is this way, it transformed our input into this way of pretty printing the list. So we do three transformations basically. So let us see if the options are also like that. So the first option is, yeah, substitute the opening bracket with opening bracket
Just
new line tab.
piping it instead of putting in a file.
Yeah, so basically instead of doing it with one set, they have done it with three sets, right? So first we are doing it one substitution, then that output we are sending it to another set, and then that output we are sending to the third set. Right? So this is also a valid way of doing it. So ideally this will take more time because we are creating multiple set instances, whereas this we are doing it in one set itself. So this should be a few milliseconds faster. So here you can see it's basically doing the same thing, right? So substitute opening with opening new line tab, yeah, and then substituting closing with new line and closing, yeah, closing with new line and closing, and then substituting comma with comma new line tab, right? So here the order is a bit different, but then in the end the output will be the same. So this is the first option. we have another correct option, which is substitute. So the first part is same. So the opening is substituted with opening and then new line tab. The closing is substituted with new line and then closing. And here, instead of like this comma, instead of substituting the comma, what they're
Anything
doing,
that is not a space, right?
no, so this caret
Or
is
starting
outside.
line, starting.
Yeah, so this is starting. So if the starting of the line is blank, then substitute. Okay, so we are searching for all those lines. So this is not inside substitute itself. So we are searching for those lines that start with something blank. So basically, when we do this, so this the first digit character here will be blank. So searching for the lines that start with blank, they're substituting comma with comma new line tab. So the substitution here is still the same, comma new line tab, but we are doing it only for those lines that start with blank. So here you may think this will not work because this line does not start with blank. But what happens is this will do it line by line, right? So because we have already done this first set, so this part is already done. So opening bracket is replaced with opening bracket new line tab. So already it is like, so if I remove this part, so what has happened using the first two sets is like this. So we have something like this. So for the second line, this is true. So it starts with a blank. So here we have a blank here. So what it is doing is substituting comma with comma new line tab for all the occurrences. So all of these commas then become comma new line tab, same as what we were doing earlier. So it is basically searching not in the first or the last line, but only in the line which starts with a blank space. So that's why that also works. The substitution is exactly the same. So we are just conditionally doing it only on those lines that starts with blank characters. And this is working because we are doing this substitution. The opening bracket is substituted with opening bracket new line tab. And hopefully this makes sense. And the second one, so what is the difference between that and the last one? Like the second and third one, what is different here? Okay, this G is not there, right? So also this order is incorrect. So instead of new line tab, it's tab new line. So this is incorrect, and then G is also not there. So it will do it only for the first comma and not for the rest of the commas. So because both of these are not there, this is incorrect. And the last one also, we don't have the comma. So the order is now correct. It is new line tab, but we don't have the G. So it will not work because it will only do it for the first comma. Right. Okay. So let's hopefully this one was clear. So let's move on to the next question. Okay, we have, I think these are fifth and sixth options. Okay, we have two more options. So here this is searching the same thing for the first two lines, and it starts with blank, blank star, and then substituting. So here again we don't have the G, right? So this ideally should work because we have stars, so this will still match correctly, but the G is not there, so it will not do for all the commas. And in the last one, again the order is incorrect, right? So it should be comma new line tab and not comma tab new line. So that's why this one is also incorrect. So let's move on to the next one. So here the question is select all the commands that print the from line 4 to line 7 of the file my file, including line 4 and line 7. Assume that the file my file contains at least 7 lines. So here we have basically options. So what we have to do is we have to print the 4th to 7th lines. So how
So
can we do
we can
this?
use in this sad also and grep also. In grep, no, not grep, head and tail.
Yes, we can use head and tail, right? So how can we do this with head and tail? Wait, let me create a file with that many lines.
Uh,
Okay, so
We
we
can
have,
take top 7 lines first.
okay, yeah. So how will we do that?
Uh, Top 7 line means head minus n equal to sorry, not equal to 7.
Yeah.
Then pipe symbol. Then tail minus n 4, I guess.
So we have to take 4th to 7th. So 4, 5, 6, 7. Yeah. So here I have to give the file name also, which is numbers. Yeah. So this will give you the 4th to the 7th line, including the 4th and 7th line. So this is like the simple way of doing it. But we can also do it with sed.
And
So
using said uh, 4, then tilt sign, I guess. No, fourth is the starting one, right? No,
yeah.
comma 7p, I guess.
Okay. So will this work? So what is this doing?
I'm starting from 7. What my thought process is, starting from 7 to starting for 4 till 7.
Yeah. And then P is printing it.
Yeah.
So, but then do we need to do anything else for this to work?
Oh, file name.
Okay, yeah, file name, yeah, we have to give. And anything else that we need to do?
We want to print this only. So maybe minus n,
Yes,
minus e.
minus n, right? So we don't want to print the other lines and print these lines twice. We want to not print the other lines at all and print these lines only once. So this will give you the same output. And how
Just
can,
if you
yeah.
can explain me the use of minus n and minus small e.
So here, if I don't give minus n, so all the lines are by default printed. So we have 1, 2, 3, and the ones which are printing will be printed by default and by force also. So 4 is printed once by default and once because I'm printing it. 5 is printed once by default and one because I'm printing it. So 4, 5, 6, 7 are printed 2 times, others are printed once. So I don't want to print each line by default. I only want to print them if I am telling it to print using the P. So minus n suppresses the normal printing.
So basically, minus n is saying whatever I want to see, just give me that only.
Yeah, so by default, it will not print a line.
And what is minus small e do?
So that is same as grep. So if you want to give multiple things to sed, you can use minus e. So here, because it is only one, we are not using, but we can
Uh,
also use here. So
if we want to give multiple commands, so that then we
yes,
use like we use in grep, right?
yes, exactly. It's exact same as grep. You can see
Okay.
I can give two things: 4 to 7 print, 1 to 2 print. So 1 to 2 is printed and 4 to 7 is printed.
Okay. Thank you so much.
Yeah. So how can we do this with awk also?
With awk,
Yeah. And the lines 4 to 7.
uh, we can use if command if n nr equal to 4, then we use end symbol to 4 times. If nr equal to 4, nr equal to 5, nr equal to 6, and nr equal to 7, and print it.
Okay, yeah. So we don't need to use the if because we can directly put conditions in the pattern of the action block. And ideally, instead of matching like all of them equality, I would usually use like the greater than less than. So
We
something
can
like nr greater than 3 and nr less than 8.
7.
Yeah,
Oh yeah,
less than
yeah,
equal to
correct,
7 or less
correct,
than
correct, correct.
8. So if we do this, and here if I say print, then this will print only those lines which are 4 to 7. Right? So I don't need the if here because I'm directly putting it in the condition of the action block.
Yeah, yeah.
Yeah,
Okay.
so these are the ways to do it in these three. Uh, what else can we do? So there can be like using other commands also we can do. So I'll not delve into too much into for one question. So let's just see the options here. So we have yeah. So the first one which we saw, right, using head. So head 7 and then tail 4. So for the first command we have to give the file so that it knows which file to act on. The tail is simply acting on the output of head. So this one will obviously not work because tail minus 4 can take any line. So it will take the last 4 lines. So if the file has, let's say, a million lines, it will take the last 4 from the million lines. So it's not the 4th to 7th. So this is incorrect. This, as we saw, is correct. So we have to suppress the output and then print 4 to 7. And this 4 minus 7 is not a correct syntax, so that's why this is wrong. And in awk, here we saw, as you told, we can use if, or we can also do directly this way. So if nr is greater than equal to 4 and nr is less than equal to 7, then print. Or we can do, for all the lines, go inside the action block, then check inside the action block if nr is greater than equals 4 and less than equals 7, then print. It's all of these are correct ways of doing it. So let's see the next question. Consider a file home user script that exists currently on the system. Below commands are run to create links. Mkdir home user links. So this folder is created, home user links. Then we are using a ln without minus s. So this is a hard link from home user script to home user links script link. So this script is a file and not a folder. If it was a folder, this would not work. So we are creating a hard link of the file home user script in the path home user links script link. And another thing, we are creating home user links script link. So the one which we just created, we are creating a hard link of that as home user links script link. So this is basically creating a two hard links. So what is like the relationship between the scripts link and scripts link? What kind of relationship? Like,
The second one will point to the first one alone, right?
okay, so this is a hard link, right?
Yeah.
So does it point to this file or how
It
does?
stores the same value, right?
Yes, so it all of these stores the same value, but this one does not depend on this one. So only while creating the link and giving the path, so it can fetch the file from the hard disk, but it is not dependent on this path. So if I remove this also, this will still work. So these are not dependent on where it was created from. So
So
these
none
are,
of these are dependent then.
yeah, none of these are dependent. So all three are independent hard links of the same file. So I cannot also say that script link is a hard link of script. I can also say script is a hard link of script link. So there is no parent-child relationship, right? So no one is the
It's like a
original one.
copy.
Yeah, all of them are exact same copy. So script link and script link, all of the three point to the same file, and all of the three are regular files. So nothing like the second and third one is a special kind of file, or they are anyway inferior to the original file. So all of these are the same kind of file. All of these point to the same file. So if we make any change using any of the paths, it will also be reflected in the other ones also. So let us see the options. So the first option is the link script link will be accessible even if it is moved to a different directory within the file system. Right. So this is true because this is a hard link. So if it was a soft link, then script link was dependent on the script it was made from. So in this case, because we are giving absolute path, it would still work even if it was a soft link. But for example, if we had given relative path from this link's position, then it would have not worked if we had moved the link. So because it's a hard link, it does not actually care about the other file. It is a file of its own. So this option is correct, but it has to be within the file system. So a hard link can never be moved outside the file system. Hard links will always have to be present in the file system itself. So the second option is the file script link and script will have the same inode number. So that is obviously true for hard links. So all the files that are hard links of each other, they have the same inode number with each
So
other.
script link, and script link, all three file will have same inode number, right?
Same inode number, yes. All of these will have same item number. So the third option is if we create a copy of the file script, then copy will also be linked automatically from the file script link. So this is obviously not how it works. So only if you like explicitly mention something to be a link, then it will do it. If you simply create a copy, it will create another file that has the same contents, but it will not be linked. So if you change that, it will not make any changes to the other three. So a copy is not automatically linked. And the fourth option is if the file script link is deleted, the file script link will be inaccessible. So again, this would have been true if this was a soft link. So if we had done ln minus s, but because it's a hard link, there is no parent-child relationship. They are siblings. So they point to the same file. So if one is deleted, the other one is not affected. They will still be able to access that file. Right? So, and the fifth option is if the file script and script link both are deleted, the file script link will be inaccessible. So again, same thing. So because they are both hard links, so they are not dependent on anything. So once they are created, they are independent on their own. So even if both of them are deleted also, the third one will still be able to access the original file. Right? So hopefully this one makes sense. So if these were soft links, then the second last and the last options would have been correct. Okay, so let's move on. So here the question is, the following bash scripts perform some operation. The script is run with some command line arguments. The command line arguments values contain only alphanumeric characters. So alphanumeric means A to Z small, A to Z capital, and 0 to 9. So this is run with arguments, and the arguments will have only alphanumerics. So we are doing args equals 0 for I in quotation dollar at, then do args.
Basically counting the number of arguments we have said.
Yes, exactly.
It's
And
taking every argument, right?
yeah, so
That's
it is
counting.
iterating over all the arguments, and it is basically incrementing the value of the args variable by 1 each time. So this will have the number of arguments that are sent to this bash script.
Just one question. Instead of dollar at the rate, can I use dollar star?
You can use dollar star if you don't put the quotation here, right? So four things. Okay, so let me discuss this again. I think we discussed it earlier. So there are four ways of accessing the arguments given to a file. So let me create a script here, script.sh, and this is a bin bash script. So here, if I do, let's say, for I in dollar star, do echo $I done. So if I run it this way, so what will happen is, let me make it executable. So if I run it, script.sh with, let's say, a few arguments. So apple, banana, cherry. So if I give it argument of single words, right? So it will work normally. But here, if I, let's say, give a fourth argument, which has multiple words. So something like this. So you can see I've given a quotation. So this means that this entire thing should be one argument, but it will still split it. So you can see by the script it is taken correctly. So the this dollar hash correctly has the value 4. So it has the value 4, but because I'm using dollar star, so this is simply putting all the arguments side by side, and a for loop will simply iterate over all the words given here. So this is same as me writing apple, banana, cherry, cherry, cherry blossom. So it will discard the quotations. Right. So here it is splitting all the multi-worded arguments. So it's splitting into multiple iterations. If I put quotations here, then all the arguments are treated as one string itself. So now it will, instead of printing 5 times, it will print just once with everything. So if you see now, it is printing everything in one line. So it is only iterating once, and everything is treated as one thing in here because we have quoted it. So you should never, ideally, if you want to iterate over them separately, you should never quote dollar star, because then it will be treated as a single string. So we saw that dollar star normally works as like taking it one by one, but if we have multiple worded arguments, it will split them. Now, what is the difference between dollar star and dollar at? So dollar at treats the arguments and put them in an array instead of taking them as a string. So if I don't quote it, then the output will be the same. So dollar at has done all the work correctly. It has stored it in 4 elements. So apple, banana, cherry, and cherry blossom is stored as 4 elements. So we can also see that by printing the dollar at's number. So I think this works. I'm not sure if this works. So if I see this, you can see the array itself has 4 elements. So $@ is storing it correctly. But in the for loop, again, what is happening is if I just iterate over it directly, it will again split it. So it will resplit things like this. So then what we do is we have this special syntax of quoting $@.
Okay,
So
if we are doing without quotation, we are facing same problem in both.
yes, but if we quote $*, then we are getting everything in single line. But if we quote $@, which is an array, then what it will do is instead of quoting the entire string, this in bash means quote individual elements of that array. So now you can see we will correctly get the multi-worded argument in one iteration. Right. So ideally, you should always iterate like this for I in $@ inside quotations. The if you are sure that the arguments don't have space in them, then you can use for I in $@ or you can use for I in $*. But ideally, you should never use for I in quotation $* because that will take everything as one string. So this is the best way because even if the arguments are multi-worded, it will preserve that. Right. So this $@ is an array and $* is a string. So here we are doing the correct way. So for I in $@ inside quotations. So even if it is multi-worded, it will preserve that. And we are simply incrementing the count of arguments. So here you can see, obviously, it will, as many arguments as we are giving, it will count that. So which of the following bash scripts is and will, what is this English? Which of the following bash scripts is and will give the same output as the, okay, which of the following bash scripts will give the same output as this script? So then we have four options. One is echo $$. So what does echo $$ do? So what is the value of $$?
Machine name, I guess.
No, it's the, it's not machine name. What is it? Anyone? Okay, so I'll print it, and from that, can you guess what it
Number
is?
of arguments.
No. So, okay, this is one hint. So this is the output right now. So what can this be?
Process ID.
Yes, right. So this is the process ID of the current bash. So if you see PS forest, so the process ID of this bash is this. So $$ shows the process ID of the current bash. So that is not what we are printing. We are printing the number of arguments, right? So how do we print the number of arguments in a script? We already did it, right? Here. We use $# for that. So that is the correct option. So echo $# will do the same thing that this script is doing. So this is basically iterating over all the arguments and increasing the count by one, then printing the count. That is same as printing $#. And the third option is basically echo $@ awk print nf. So what is this and why will this work? What does this mean? So what is nf?
Number of fields.
The
Yes, number
number
of.
of it
Yes,
just
so,
print the number of files, right?
not number of files, number of fields. So number of
Number of
fields means number of columns in the each line. So this echo $@ how many lines does this print?
Also, echo dollar will be vertical or horizontal.
So usually how does echo work? So if I give echo A, B, C, so it prints everything in one line, right?
Okay.
So if I do echo $@, it will print all the arguments in the same line.
Same line.
So there will be only one line. And
So it is printing the number of field of the last line, I think.
yes, so the last line is basically the only line that we have. So that last line, the number of field, and this only works because we have been told this. The command line value contains only alphanumeric characters. So it is told that no argument is basically of this form, right? So multi-worded. All of them are single worded. So it
Okay.
only has
Otherwise, if it would have taken cherry blossom as a one.
separate. Yes, yes,
Separate or
exactly.
one?
No, it would have taken it as one. Yeah, sorry, my mistake. So it would have basically printed 5 here instead of 4. So because we are guaranteed that nothing of this sort will be given, so if we just have this, so if I just echo this, right? So output of echo will be like this. So if I pass it through awk and I tell it that after you have processed everything, you just print the value of nf. So the value of nf was obviously changed only once for that one line. So it will simply print how many words there are. because awk by default splits by white space. So we have this space, so it will split by the space and count the number of fields. So this option is true only because this alphanumeric is told. Otherwise, this would not work. So for example, if we had something like this, right? So cherry blossom. So this obviously, if you even just print it, you can see what happens is even if I have quoted it, the output will be like this. So there is no separation. So if we then pass this over to that same awk, it will obviously print 5 uh, instead of 4. It's printing 5. So this is correct because we have one assumption told in the question. And the fourth one, which is also correct, is doing echo $@ and using WC minus W, right? So what is WC minus W?
Word count.
Yeah, so minus W will print only the count of words, right? So WC can print count of lines and count of bytes also. So minus W will only print the count of words. So if I basically do this and do WC minus W, we get how many words there are. So again, this one is correct only because this presumption that we have in question. So this will always work, second option. Third and fourth only works because of that assumption. Right, so let's move on. Which of the following commands will print the lines that do not start with hash, single quotation, or 2 forward slashes? So we have given a hint that we can use minus V to invert a match. So I want to find lines that do not start with hash, quotation, or slash slash. So let's think about the solutions ourselves first. So how can we do this with grep? Let me create a file. So I have some lines, and some lines is like a comment. So that starts with a hash, and some line starts with a single quotation, and some line starts with a slash slash. Right. So like different ways of commenting. So this is how you comment in Python, and then this is also how you comment in Python with, like, if you have 3 quotations this way, and this is how you comment in C and Java, etc. So how do we print only those lines that don't have these using grep? Any idea?
So egrep,
Yeah.
then square bracket. No, sorry, open bracket. Then hashtag.
Okay.
Then pipe symbol.
Okay.
Then uh, inside double quotation mark co- one quotation.
Double quotation will also be taken as a literal, so that will not work. You want to put the quotation, right? So you have to escape it here. You have to do it this way.
Okay. Then again pipe,
Yeah.
and then I guess double backslash
Forward slash, right?
forward slash, and then bracket close.
Yeah.
Though this will give the lines that contain this. I don't want this, so minus V. Then we need to use
Okay. Anything else?
file name, I guess.
Okay. So the question is, which of the lines do not start with these symbols?
Okay, start with. So we need to do the upper sign, that upper tilt sign.
Caret symbol, right? Yeah. So we put the caret symbol here before the pattern. So this, okay. Okay, I think this quotation is causing the issue. So once again, let me make this entire thing double quotes itself. Let's see if that works. Okay, yeah. So you can see that you can use this. So we ideally here don't need the grouping. So if we remove the grouping also, this should work. So the OR will simply take either hash or the single quotes or the slash slash. So things that don't start with that. So if, let's say, we have one that starts with single slash, so that should still be printed. So yeah, that is printed. Only things that starts with double slash is not printed. So this is one way to do it. Another way would be, so we can uh, like you can, instead of doing this, we can also do this. So that is also fine. So this is another way. So instead of writing double slash, we can also do this. What else? I don't think there is any other way. So let us see the options. So the first option is egrep v starts with hash, pipe starts with quotation, pipe starts with escaped forward slash forward slash. Right. So here, I think the issue is because we have put the starts with three times.
This is already egrep, so we don't even need to put escape, right?
Yeah, so the forward slash anyway, you don't need to escape. So they have also escaped that. So this one is not correct. So it will not print the lines.
So it's wrong because of escape character or because of that starting character we are using three times.
Okay, let us write it out and test to see that. So if we have
I
grep,
guess it should be because of escape character.
yeah, sorry.
Uh, uh, I'm guessing. I'm not 100% sure.
Yeah. So I'm also not sure. So I'm just writing it out to see. So starts with hash, pipe, starts with quotation, pipe starts with escape forward slash quotation, and then define as test. So here you can see it gives us a warning that stray backslash before forward slash, but it seems to print things correctly, right? So the output will come, but it will give us a warning that we have this escaping, which is causing the issue. So if I remove this escaping, then we will get the correct output. So this escaping is not required because forward slash does not have any special meaning in grep. So whether it is ERE or BRE, in both cases, forward slash does not have any special meaning. So we don't have to escape it.
But we should consider this for answer because warning doesn't matter, right?
Yeah, but then the output
At the end,
has,
he's asking for output, not the warning or error.
yeah, but that is also part of the output printed to the screen, right? So yeah, that can be argued as the correct answer, but if we consider like line by line equality with the expected output, like we have for the like VM tasks, etc., right? So in that case, this will not match because we have one extra line printed. But like the output is correct. Yeah. So in that case, the this is correct. So if we did not have this, then everything would be exactly the same. So then you can see this one where we are not using egrep. So there we are escaping basically the pipes because the pipes uh, do not have any special meaning directly. We have to escape them. And here we are escaping the backslash. So here it is not causing an issue. So let us try that also. So let me simply remove the E from here and we escape the pipes and also the forward slashes. So, okay, so here also we are getting this error, right? Because the forward slashes do not have any special meaning either in BRE or ERE. So this, ideally either first and second both should be correct or first and second both should be incorrect because both will give you the output, but both will have this warning because we don't need to escape the forward slash in either BRE or in ERE. So in the third one, what is the difference between the first one and the third one? We are escaping both the forward slashes, right? So, okay, I think the reason this is marked incorrect is this was assumed that the forward slashes need to be escaped. So because only one is escaped here and here both of them are escaped, it's marked correct. But that is not true. So you don't need to escape forward slashes. So in this case, first, second, third, all will give you a warning and then give you the correct output. And the fourth one should also work with a warning because here also we are doing the same thing. Right. So just make sure if you're using egrep, then you simply use the pipe, and if you're using without egrep, then you have to escape the pipes. So if that is there, then everything else looks correct. So the fourth one also looks correct with a warning, and the fifth one is the most correct without warning. So here I think the answers are marked incorrectly in this question.
So what's the literal meaning of pipes in grep?
So literal meaning means it will search for that symbol. So if you have pipe in a file and you want to search for the existence of the symbol pipe, then in grep you will use the pipe to directly match it. Whereas in egrep, if you want to literally match a pipe, you have to use the backslash.
So, sorry, if we use pipe in grep, it will
Yes.
start searching for pipe symbol.
Yes. That is what
Okay.
literal means, right? So it
Okay.
will match that exact symbol.
So we don't want that. That's why
Yeah.
we are using that back.
Yes. But if you escape it in egrep, then again it will search for the literal pipe.
Okay.
Yeah. So and then the fourth last one we have, why is this incorrect? Okay, so the same reason, right? So this also is correct. So if you have escaped the pipe correctly, so you don't need to escape the forward slashes. So this all the options look correct, although some of them throw errors, whereas the last two don't throw errors. So the last two can be argued to be more correct than the other ones. So let's move on to the next one. So in this, we have a awk script given to us. So begin fs is comma, ofs is colon. So fs is the input field separator and ofs is the output field separator. So we are telling that split the columns using comma, but when I am printing multiple things, separate them with colon. So then for each line, we have some a variable sum equals 0, and then we have a for loop from 1 to equal to nf. So for all the columns, we are running a for loop, and for each column, so $I basically will be $1, $2, $3, etc. So for each column, I am doing this condition checking. So if $I minus, why are we subtracting a regex? I think this should be tilde. Yeah, this should be a tilde symbol. So we are checking for regex. So if $I matches this regex, so what is the regex that we are searching for? So there can be a plus or a minus symbol at the starting, and question mark means it might be present or it might not be present. So
Means 0 or 1 occurrence, right?
yes, so it is either
But
present 0 times or 1 times.
pipe symbol mean or na, or without pipe is also or.
Pipe symbol means or in ERE, and in BRE it has literal meaning. So here we are not using the pipe. So here we are simply using the like question mark to say either the minus symbol or the plus symbol can be present or it may not be present. So if it's present 0 or 1 times, and then we have digits present as many times as it wants, so 1 or more times. So if we have 1 or more digits, and then we have a dot, so backslash dot means we are escaping this. So this is not any symbol, this is the literal dot. So that is also question mark, so it might be there, it might not be there. And then again we have digits star, so 0 or more digits. So what does this match, this entire regex?
Positive, negative numbers also with decimals values.
Yes, with and without decimal values, and with and without sign, and it can be positive or negative. So any real number basically. So this, I'm assuming this is until there. So if the $I, so if that column is a numeric column, and we also have this starts with and ends with. So not just it contains a numeric value, the field is only a numeric value, nothing else. So then sum plus equals $I. Right, so we are going over all the fields in that line and we are summing that fields. And else, if that column is not a number, then we print invalid data and exit one. So we simply stop the script. And then what we are doing is for each line, we are printing the sum. So this will basically go over each line in a file, and for each line it will add the value of all the columns and print the sum. So for each line it will print one line to the output, which is the sum of all the columns. and if any line has any non like numeric column, then it will print invalid data and stop. So the question is, it has sub questions. The first question is, select all the correct statements with respect to the given awk script. The field in the input to the script are comma separated. So yes, because we are using fs equals comma, so the fields will be comma separated. The second option is, the number of fields can be at most 5. So here you can see we don't have any hard coded value. We are simply using nf to iterate till nf. So if nf is 1000 also, it will iterate from 1 to 1000. So we don't have any limit on the number of fields. So the number of fields can be anything. So this option is incorrect. If any of the field values is 0.123, then invalid data will be printed. Right? So why is this true? In this,
Because plus minus we want, right?
no, no, plus minus we have question mark. It can
Oh,
be,
okay, zero occurrence also.
yeah. So why is dot 234 will give you invalid data?
Because digit plus, that means one
Yes.
and more.
Yes. So we have to have something before the dot. So if it is a less than 1 also, it should be 0 point something, not simply point something. So in this regex, something which starts with dot will not work. It has to be some digit and then dot and then some digit. So this one will is correct. It will print invalid data. And if any of the field value is plus minus 1.23, then invalid data will be printed. So why is this correct? Plus minus 1.123?
Because zero or one occurrence, there are two occurrence.
Yes, because question mark means 0 or 1. So if you have two occurrence, then this regex will not match. So that's why this one is also correct. It will print invalid data. If any of the fields contain an alphabet, then invalid data, obviously we saw that it only matches. The entire column should be numeric. And the last is, the fields in the input are colon separated. So this is not true. OFS colon means the output is colon separated. But anyway, we are not printing multiple fields. So the colon is not used even anywhere. So the input is comma separated and not colon separated. Right. So that is why these options are correct. So let us see sub question 2. So select the output of the awk script on the input given below. So if this is the input, then what will be the output? So the script basically goes over each line and adds all the values and prints the sum as output line, right? So what will be the output?
First six.
Yes, and then 1 plus 2, this is 6.3, right?
Right.
6.3. Then this one,
5.2 minus 1.1. So 4.1.
4.1. Yes, so 3 plus 1, 4.1. And then this one,
3 to 5, 6.3 same.
yes, and then,
Invalid and again invalid.
okay, so two invalids,
Yes.
but we have exit 1 here, right? So after printing invalid, the script itself will stop with exit code 1.
Oh, exit means we are out of loop or out of the script only.
So if we have the word next, next, then that means skip this line and go to the next line. But exit means it will stop the entire script totally. So if we have exit 1, then it will exit the awk and it will return the exit code of 1. So it will not go to the next line anymore. So it should, for the next one also, it should have been printed, but because the first one itself is exiting, so it will just print invalid data once. So let's see. So obviously the first one is not correct. It is not going to print invalid data for like at the first itself. So it will do each line one by one, and only when it is encountering this, then it will print invalid data. So this is incorrect. So the next option is this one. So as we saw, only one invalid data. So 6, 6.3, 4.1, 6.6 invalid data. So the this option is we have 2. So here they're basically claiming that this will a plus b plus 2 will give you 2. So that is not true, because as we saw, any non-digit will give you invalid data. And the last is basically saying all of this will work. So even the last one will also work. So it will basically give you 80, 90.1 or something. Okay, no, it's telling it will give you 1 for some reason. So obviously this is also not true. So the here itself the script will stop with invalid data. So thankfully here you don't have an option which has this and then the same thing with two invalid data. So if that was the case, it would have been confusing what to do. Although obviously,
I would have done that.
yeah, although this is the correct option because we are doing exit. So we are stopping there itself. So this is why this is the correct option. Okay, so let's move on to the next one. So consider a bash script named runall written for some purpose located in the current working directory. Note that in the current working directory, the scripts are named with extension .sh and no other files or directory use this extension, but files directories names may contain the string sh in their name. So it is not ending with .sh, but it may contain sh anywhere. There can be spaces or tabs in the file directory names in the current working directory. Some of the bash scripts, including runall, may not have execute permissions set on them. So we have this script called run.sh, and that is present in the current working directory. And the current working directory may have other scripts that will always have .sh at the end. And it may also not have execute permissions. The options are same in the sub questions. The answers are different based on the intended purpose. So based on the above data, answer the sub questions. So first we are telling purpose of runall.sh is to execute all the bash scripts in the current working directory only once, excluding runall.sh. So runall.sh is also one of the files in the current working directory, but we obviously don't want runall.sh to execute runall.sh, right? Because it will create an infinite loop. So execute all the bash scripts in the current working directory only once, excluding runall.sh. Select the options below which has the correct script runall.sh along with the command to run the script successfully always as intended. So we have the first option which is doing a pattern which is ends with .sh, right? So for all the files that ends with .sh. So here again I'm assuming this is a tilde, so it looks like a formatting error, but yeah, so for matching regex inside double box bracket we use equal to tilde, not equal to minus. So for name in star, do if dollar name matches the pattern dollar pat, then bash dollar name. So multiple things wrong with this. First of all, so the pattern should never be put in double quotes. So if you have okay, no, so but we have not put it here, so okay, that is not an issue. But the issue here is it is also executing runall.sh itself, right? Because we are not checking if the name is a runall.sh. So as it's told, we don't want to execute runall.sh. So that's why this is wrong. Another is as it is told that there can be spaces or tabs in the file or directory names. And as we saw, if we simply do a for loop like this, so for name in star, so this star will give you all the names, but the for loop will then break the files which has spaces in them. So this will even not work for files with multiple words in them. So this option is incorrect. So this is the second option. So here also like that issue is there for star not work, like for the for loop not working. So here instead of checking with a pattern, what we have done is we are only iterating over for name in star.sh. So this will expand to all the correct script files. But here also again we are not checking that the file is okay. So here we are checking actually. So we are checking if $0 does not equals dollar name, then bash. But here again that for loop will also break those files which has multiple one or more spaces in the name. So this will not work. And the third one, so here you can see what we have done is same as the previous one, except we have put quotation in the dollar name. So this is a little better because if the dollar name has multiple words, right? So if we don't put the quotation, then the bash will try to run a script with just the first word of the name, so which will not work. Whereas this will correctly run the entire script correctly. But here also that issue is there that the for loop will not work correctly for the script with multiple words. So this one is last one is correct. So uh, okay, so here is also the for loop is iterating over that. So that is still marked as correct. Okay, but the difference in this one is that we are making the runall.sh executable. So earlier we are doing bash runall.sh, whereas here we are doing chmod u plus x runall.sh and /runall.sh. So there are no other differences. So we have to obviously keep this in quotations. So if we don't keep it in quotations like this one, then if the file name has spaces, then it will break and it will not be able to execute that. So here putting them in quotation is the correct way. And if I run it, okay, so here the issue with the previous one is we are running it as bash runall.sh. So for example, if I have a script called runall.sh, and so here what we are doing is we are checking $0. So if I print $0, so if I execute this with bash runall.sh, then it prints runall. And if I make it u plus x runall.sh dot slash runall.sh, then the output is dot slash runall.sh. So you can see the difference in output. Here it will only print runall.sh and here it will print dot slash runall.sh. So because we are doing this for name in dot slash start.sh, so all the files name will also have dot slash in them. So when we are doing this comparison, $0 does not equals $name. This will even for run all it will not work because here if you're running it with bash, $0 will only contain runall.sh, whereas all these will, so when it is run all in the for loop, it will be dot slash runall.sh. So we will be comparing runall.sh does not equals dot slash runall.sh. So even for run all it will try to execute it. So this is not correct. So if we are executing it this way with dot slash runall.sh, then $0 will be correctly set. So then we can do this comparison. And here we should quote the $name because the dollar, like the name of the file, can be multiple words also. So let us try to see if this works. So let me create a few files. So let's say uh, a.sh where we are echoing a, b.sh where we are echoing b, and let me add a multi-word. So a, b, c dot sh, and here I am echoing a, b, c. Okay, so you can see we have these scripts runall.sh and then a.sh, b.sh, and then a space, b space, p.sh. So in runall, if I do this one, which is the last option, so for name in, okay, wait. No, this is the last one, yeah. So we have other options after this. So this is for name in dot slash star dot sh do, and here we are checking if $0 does not equals uh, $name. So here we have to code the $name because it may have multiple words and we don't want it to be splitted. So then we will simply use bash $name. And again, here we code the word because we don't want it to split even if there is multiple words in it. And then, okay. So this is the script, right? So for name in dot slash start.sh do if $0 equals or does not equals name, and dash $name. Yeah. So let's see if this works. So first let me make chmod u plus x runall.sh, and then I will do dot slash runall.sh. Okay, so it works correctly. Why is this printing 0 also? Okay, we have the script.sh in it, that's why. So let me also print which script we are printing. So let me say echo running $name. Okay, so you can see we are running this dollar script also that's printing this 00. So let me remove that dollar script.sh temporarily. Okay, so yeah, you can see in this way we are getting it correctly. So it's printing this. But if we, instead of this, if we run it this way, bash runall.sh, so you can see it will run that script also, right? So it will run ABC, it will run A, it will run B, and it will also run again ABC, right? So you can see inside also it's keeping on running. So that is not correct. So if we are running it with bash ABC, bash runall.sh, then this equality will not work. So that's why that is incorrect, and this option is correct. So in the next option, we are basically checking the same thing. So here we are checking if the name is not /runall.sh, and but then here we are not quoting it, right? So because the name can be multiple words, if we don't quote the variable, this will cause this if condition to error out if there is any file which has spaces in them. So that's why this will not work. And this last one also works if we run it with bash, because here again in the for loop, instead of doing /star.sh, we are doing for naming star.sh. So this one will give you the names without dot star. And as we saw, if we run something with bash, then the this $0 will also give you only runall.sh, and here we are anyway just comparing runall.sh and not $0. So we are checking if $name quoted is not equal to runall.sh, then we are running that using bash. So that's why this option is correct, and this option is correct, and the other ones are incorrect for the various reasons. So here we are not quoting $name, and here obviously we are not checking if runall.sh is run or not. And the third one, here the issue is we are running it with bash, but here we are getting the names with dot star, so that will never match. The fourth one is correct, and the sixth one is correct, and fifth one again incorrect because we are not quoting the $name. Right, so hopefully this makes sense. So this is a big question. So we have 6 options here. Out of this, only 4 and 6 is correct. Right, so let's move on. So only 3 pages left. So again, we have the same options given to us, but now the purpose is different. So purpose of runall.sh now is to execute all the bash scripts excluding runall.sh in the current working directory only twice, irrespective of the number of times runall.sh is executed. So here we want to run all the scripts exactly twice. So we don't want to run it once or 3 times, only twice. So here the correct option will be this one, where we are running it with bash runall.sh, but we are checking with dot star. So why this is true is because, as you saw when we ran this, so if I run it with bash, so the first time it will run the other scripts, ABC, it will run A, it will run B, then it will run runall.sh also. But although we started running it with bash, here it is also running it with bash. So here what will happen is uh, the name will change again to dot star. So initially the $0 will be runall.sh, but here we have it in /runall.sh. So when we are running it in bash /runall.sh, then the name will match this one. So for the next time, it will not execute runall.sh again. So the first time runall.sh is run, it will run all scripts along with runall.sh, and then that runall.sh will run all the scripts, but not runall.sh again, because this time the $0 will be correctly set. So as you can see, it is only running 2 times. Right, so that's why this option is correct and the other ones are incorrect. So that is this paper, 22 January, May term, I think. Yeah, 22 May term. Just let me know if this one was clear, the last 2 questions.
Yeah.
Okay, yeah. So let's end the session today. And in the next session, which is on Saturday, we will do this one, 22 SEP. Before that, I would have completed 23 May and 23 SEP in the TS sessions. If you are available at that time, join the TS session. If not, I will share the recording. So just watch it whenever you're free. If you want, you can watch in like 1.5x, 2x, etc. So just before Saturday. So this will be Thursday and this will be Friday. So if you can join the session, otherwise I'll send the recording in the mentorship group. So let's stop the recording.